right, we are continuing, everybody, with 1-5. Parent functions and transformations. You guys need to get your graphing calculators ready. We're going to be doing some piecewise functions. Piecewise functions. Everybody, this is an example of a piecewise function. Okay? We're going to have three separate functions that we need to do. I'm going to highlight them in blue, red, and green. We're going to be focusing on this one, and this one. We're going to do it by hand without the use of a graphing calculator, and then we're going to do it with the use of a graphing calculator so you know how to type it in where you could actually graph those three functions and just those pieces of those functions. Okay? So right now, we are going to start with the blue function. The blue function says f of x equals -1. I want you to know that just means y equals -1. That's the function that goes with the blue one. The red function.
If x is equivalent to -3 or less than 3.
Right. So that's the domain. So all of these right here, this is your limits. You're limited to this domain. Your red function is y equals 1 plus x. I'm just going to write x plus 1. And the green function is y equals the greatest integer of x. This is your step function. Now what we're going to do is we're just going to graph these like if we were to have 3 graphs on your paper. We're going to graph them. Then I'm just going to erase to what we need. Okay? So right now, the very first graph I'm going to graph is y equals -1, which is simply a horizontal line right along the parallel to the x-axis. So what I'm going to do is, I'm not going to make any arrows with this. I'm just going to make some lines. We're going to go nice line that goes all the way across like that. So on your paper, just wait. Don't do it in pen or anything like that. This right here, this is without the domain being limited to just x is less than or equal to 3. So what we're going to do now is we're going to look at this. And we're going to limit this function's domain to where x is less than or equal to a -3. So you go over here, 1, 2, 3. This is where x is a -3. You put a point right there. And the only part of the graph that you're allowed to graph is points that are less than or equal to -3. And so that right there is the piece of the 3 functions. That's the blue part right here that we graph. Now I'm going to focus on the second function, y equals x plus 1. This is a linear function. Okay? So this is a linear function. Right here, here's the y-intercept, right there at a 1, and we're going to go up 1 and over 1. And you can continue to plot those points and graph them. Now we're not going to graph all these points, but if I graph the whole line, this is what the line would look like. All the way through, slope of 1, and a y-intercept of 1. Now, we're only supposed to plot points where x is less than or equal to a 2. So I'm going to go over to right here and put a solid dot right there. And greater than a -2. So I'm going to go all the way to where x is a -2, and I'm going to put an open circle right there. The only points I'm allowed to plot are between where it's a -2, right here, equal to a -2, and right, a 2 and a negative, like that, letter circle. So right here, this is where x is -2, this is where x is a +2. These are all the points in between, including the +2. There's the equal sign. Okay? Less than or equal to 2, greater than a -2. This is the piecewise function that goes right there with this red function. All right, last but not least, we have the greatest integer function. So if I were to graph this, I would start right here at 0. I would put an open circle, and I would connect in between. This right here's you're going up. Every single integer of y, you're going up. So the domain for the greatest integer function is all real numbers, and the range is only integers. Only integers are being plotted through the y values. All of your x values are technically being plotted. So we have this graph going up and also going down. If the domain was not limited, there were no constraints. However, this piecewise function has a limited domain. This is what it would look like if I did not have a limited domain. This would be the step function, or the greatest integer function. But we have a limited domain. We're only allowed to go from where to where? From when x is a 6 all the way down to a 4. So we're going to count over 1, 2, 3, 4, 5, 6. So we're going to go up to where x is a 4. Equal to, right? So equal to is right here. So I'm going to erase everything that is underneath that. Everything now, that just is gone. Because that's where x is a 4. Then we're going to go over to where x is equal to a 6. Where x is equal to a 6 is just where? Just that point. So I'm going to erase this, and I'm going to erase everything over except for that little tiny point. So this one kind of looks a little different. And honestly, the graphing calculator doesn't actually plot that point. But it says we can, what? Plot this one point because we're technically, what? Equal to a 6. If I took this away, everybody, if this was not equal to, if I said just less than 6, then you would just erase it. Okay, and you'd have 2 little steps. Okay? But since it's equal to, but alright, now we're going to use the graphing calculator to do this instead of doing it by hand. Okay? I prefer it by hand, but if you guys need help using the graphing calculator, this is what you can do. We're going to make this exact window in our calculator. So x minimum goes over 1, 2, 3, 4, goes over -5. Our x maximum looks like we're out to an 8. Make the x scale a 1. We're counting up by ones. The y minimum is at a -3. The y maximum we get up to 4, 5, 6, 7. And the y scale is a 1. So we're going to type this into our graphing calculator right now. So go to your calculator, go to window. We're going to make the x minimum, what was the x minimum? -5. Okay, maximum was an 8. Okay, scale we're doing 1. Y minimum -3, and the y maximum 7. And make sure your y scale is at a 1. So when I hit graph, this graph right here should be the same graph that is on your paper right here. Okay? So right now we have an empty graph. We don't have any functions yet, but your window settings should be this right here. So make sure those are your window settings. When you get that done, we're going to hit y equals. We're going to type in 3 different functions. Okay? The first function I want you to do is I want you to put parentheses. I want you to type in a -1 and close parentheses. And I want you to hit graph so you understand that that's what the graph would look like if you did not limit the domain. Okay? Now, what we're going to do is we're going to go over here to the right. Very important that you put it in parentheses. Not necessarily on this one, but in the future, definitely. So get in the habit of putting things in parentheses. We're going to open up a parentheses again. We're going to graph where x is simply less than or equal to a -3. So you're going to type in an x. Now here's the keystrokes you need to know. Second math. Second math. There we go. Second math. Number 6 is less than or equal to. And we're going to type in a -3. I'm going to close the parentheses. Now, when I hit graph now, you'll notice that the domain has now been limited to just this section of the graph. Okay? So, you can clearly see that it starts right here and it goes towards the left. So I'm going to go once again over the keystrokes. To get to that inequality sign, hit second and then the math button, and that will bring you to the inequality sign that you need. Go to y equals. Go down to y2. Type in x plus 1. Hit the graph button. You can clearly see that this line continues to go on forever. This domain has not been limited. How do we limit it? Okay, this is where I need you guys to understand. This needs to be in parentheses. So what you're going to need to do is you're going to need to do parentheses x plus 1. Then close it, hit divided by, open it up, and now we actually have what's called a statement. Our statement was what? X would have to be less than or equal to 2 and greater than a negative 2. So how do we write this in the graphing calculator? We're about to do that right now. The first thing I want you to do is hit X. And I want it to be simply greater than a negative 2. So it's second math number 3. Negative 2. That's one of the things we needed, correct? That's one of them. The other one that we needed was we needed x to be what? Less than or equal to a positive 2. So we want it greater than a negative 2. So we want it the other part as well. So I'm going to say, how do I type in the word and? Hit second math, go to the right where it says logic. So instead of here, where you have all the inequality signs, just move to the right where it says logic and select and. And you're going to type in x, second math, is less than or equal to, which is number 6, a positive 2. And you better close the parentheses after you do that. So I'm going to leave this up here. This statement right here, everybody, means x is less than or equal to 2 and greater than a negative 2. That's what this statement right here means. How are you able to build this statement? You have to use the what? The second button and the math. Come on, second math. There we go. Try it again. Second. I'm skipping it. There we go. Second math. There we go. Second math. There's the math button. Sorry, I had to walk closer to the screen. That's how you get to your and statement. That's how you get to your inequalities. Now, if you look at your y equals and hit graph, you will now see that your linear function now is limited. Now, what does the graphing calculator not do? It does not put in open circle here and a closed-in portion right there. Just like that doesn't give you a nice dot for you to understand what's including and what's not including. The last one. The greatest integer. Go down. I'm going to go over here to green. Go down to y5. Okay. I'm going to open up the parentheses. I'm going to hit the math button and you go to the right where it says number and choose number 5, which is greatest integer. So right now, open the parentheses. Hit math, right arrow, number 5. Open parentheses, math, right arrow, number 5. Type in an x. Close the parentheses, and hit graph. And you will clearly see that we have a step function going all the way up with no limited domain whatsoever. How do we limit its domain? We need to go over here, go down, go all the way to the right, hit divided by, open parentheses, and we only want what? X is between a what? 4 and a 6. We have two things. We have to write x is less than or equal to 6 and greater than or equal to 4. So what are we going to have to do? We're going to have to write a statement like this. We're going to have to say x is greater than or equal to 4 and x is less than or equal to 6. That's what you're going to have to write in the graphing calculator. So I'll be quiet and I'll just do it. You can follow the keystrokes. Is greater than or equal to 4 and x is less than or equal to 6. And you hit graph. Now, you'll notice something. It starts here, ends there, starts here, ends there. What does the graphing calculator not put right there? It doesn't put a dot because it's not recognizing it's equal to a 6. All right? So it doesn't fill in that part. So you kind of have to know that before you just use the graphing calculator. All right, if we check the table right here, you see how the greatest integer, it actually is plotted on the table. When x is a 6, there is a y value. It just doesn't what? It doesn't show up on the graph. Okay. Now, where are all the errors coming from? These are all the points that you're not allowed to plot. This is the domain here's the range for these functions. Okay. So here, when you plot a -2, you have what? You have an error. But if you go over here, you plot a -3, you have a -1. So this is your range that you are not allowed to plot. What I'd like us to do now is go to the next problem. Look at number 8. And what we're going to graph right now is we're actually going to graph problem number 8 without a graphing calculator. So right now, what I'd like you to do is we're going to do this graph in blue. Okay? And without the use of a graphing calculator, we're going to do this graph right here without even using a calculator. So right here, what I want you to do, on your paper, write down f of x equals x cubed. We're going to make a little table. Okay? We're going to make an x and a y table. We're going to plug in a -2, -1, 0, a 1, and a 2. So write that table right there. Somewhere on your paper, it doesn't have to be big. It's not a very big table. All right? When you plug in a -2, you get a -8. Because -2 times -2 times -2, -8. -1 cubed is a -1. 0 times itself 3 times is 0. Then we get a 1, then we get an 8. We're going to carefully plot these points. Now we can't plot a -2 and a -8. But that still will help us know where to plot. We can plot these 3 points, but notice, in a cubic function, they're not going to connect like this. It's not a linear function, it's a cubic function. So what I want you guys to understand, we're going to be coming way down here from -8. It's going to go up. It's going to curve through this, and then it's going to curve up really steeply until it eventually hits an 8 when y is equal to 8. So this is right here. Here's your cubic function. That's your parent function for all cubic functions. Now, what we're going to do is we're going to use this graph to graph this one. So there's actually 2 things that are happening in g of x equals the absolute value of x plus 1 cubed. There's 2 things that are happening. So we're going to talk about those 2 things. One of them is we have what's called a horizontal translation. So I'm going to write down right now, I have a horizontal translation. We've taken copious notes over all of these different types of transformations. So everybody should know what a horizontal translation is. What number would I have to plug in right there to make all of this equal to 0? -1. So we have a horizontal translation. We're going to say 1 unit to the left. So that's what I want everybody to do with a different color, is I want you guys to take this graph right here and simply take every point and just move it 1 unit which direction? 1 unit left. Now listen, make sure don't color anything in just yet, all right? There's a reason. So right now, don't color it in. You can do it with a pencil. But right now, I'm just sliding everything just 1 unit to the left. Okay? So right now, does everybody see how this is just slid over? Okay? That's the first part. The second part is dealing with the absolute value bars. Okay? So what in the world do these absolute value do? You're right. It makes all the negatives positives. But negative what? It makes what negatives? Negative x and y. That's what we got to figure out. By the way, when I say g of x equals the absolute value of f of x, okay? What's happening? That means all my y values that were negative are now positive. All the y values that were negative are now positive. Let me explain to you what that means in the graph, okay? When I have absolute value bars around the function, that means I am taking whatever is evaluated and making it positive. So right now, all the y values that were negative are going to become what? Become positive. Now where are my y values negative? The y values are negative right here. So right here, this point is actually not going to be here anymore. It's going to be right up there. And so what did go down like this is now going to be a perfectly symmetrical, and it's going to go up. So right here, I want you guys to understand that right here, here's the x-axis. Anything that was below the x-axis is now going to reflect above the x-axis, and your final answer for this problem, it's going to look like this. Okay? So anything that was below the x-axis, which was all those y values were negative, are now going to become positive. So everybody, this is your final answer without using the graphing calculator. Now we're going to go ahead and check it real quick. So while you guys are doing this, I'm going to go ahead and type it into the graphing calculator. Going to hit the window button. I'm going to change everything from -5 to +5. Do -5 to +5. Hit y equals. Clear all these out. So you don't see those anymore. And we're going to look at the original function. The original function was what? X to the power of 3. There's your graph. Now, if I said y equals, and I put in parentheses, x plus 1, close parentheses, to the power of 3, you should see what? You should see everything do what? Slide one unit to the left. Okay? But if I put absolute value bars, so check this out. If I go down here and I say second delete, I'm going to insert what? Absolute value bars. I'm going to hit alpha window and then enter. Oh, I can't insert. Oh well, I'll just clear this out. Alpha window enter, and inside of it I do parentheses x plus 1 close parentheses to the power of 3. Then when you graph it, what happened? All of the y values that were what? That were negative, right? What happened? They became positive. Okay? All right, on problem number 9, what I need, 9 and 10, what I need you guys to do is I need you guys to scale everything by 2s. So when you're doing these problems, okay, our x minimum is going to equal a -10. Our x maximum is going to equal a +10. Our x scale is going to equal 2. Our y minimum is going to be a -10. Our y maximum is going to be a +10. And our y scale is also going to equal 2. You're going to have the same scales for both problems. So make sure you, before you guys do those, make sure you set that up. This is what your window should look like. Okay? This is the distance between the tick marks on the axis. Alright? So your graph, when you hit graph at nothing, that's what it's going to look like. First, we got to take out these graphs. Alright? And so what you can do is you could graph the three functions. What are the 3 functions? Right here. So in your calculator, you can graph this function, and this function. So you can start by graphing the functions. What I would do first is I would put all of them in parentheses. I do parentheses, type in the number 4, go down, do parentheses, type in x cubed, and do parentheses, type in the square root of x, second, x squared, x plus 3, right arrow, close the parentheses, and then, hey, I'm going to hit graph. These are the 3 graphs without the domain being constrained or limited, okay? So what are you going to have to do on your own? What are you going to have to try to figure out is, these are the 3 graphs, but what do we need to limit? We need to limit the domain. So see if you guys can do that on your own. If you're able to do that, you'll get 3 answers. By the way, you're going to have to take this guy right here, and you're going to have to divide it by this. You're going to take this and divide it. You have to write it. You have to write an AND statement for this one. You're going to have to take this and divide it by this right here. And that will help you get those 3 graphs accurately. Good luck.